Now we are just starting with the revision of the concepts of law of conservation of linear momentum. Now according to that principle, what do we know? That if an object is having a mass of m1 and it is having an initial velocity of u1, let's suppose assume there is another particle which having the mass of m2 and it is having an initial velocity of u2. Both are traveling in this direction. M1 is traveling in this direction, M2 is also traveling in this direction. Now, after the collision, what happens that M1 started moving in that direction with a different velocity, that is of v, and M2 started moving in that direction with a different velocity, that is of v2. Now in this case we are just going to derive the mathematical expression that before the collision and after the collision the total momentum of these particles will be conserved. That means the change in momentum will be equals to 0. Therefore we can write down the mathematical expression as m1 u1 plus of m2 u2, that is equals to m1 v1 plus of m2 v2. That kind of mathematical expression will derive for the principle of conservation of linear momentum. Then you have to derive what is m1 here, what is m2 here, what is u1, what is u2, as well as v1 and v2. Now m1 is the mass of the first particle, m2 is the mass of the second particle, u1 is the initial velocity before collision of first particle, u2 is the initial velocity before collision of second particle, v1 is the final velocity after collision of first particle, v2 is the final velocity after collision of second particle. Okay, I hope this part is clear, and you have to remember that mathematical expression to derive any mathematical expression for the application of conservation of linear momentum. Now we are just proceeding to the next topic. Now when a bombshell is fired, this is the first application that we are going to analyze. When a bombshell is fired, initially the bombshell was fixed. Now initially if the bombshell was fixed, therefore the initial momentum was 0. That means all of the particles in the bombshell is at rest initially before the bombshell was fired. Right? Now if they are fixed at their position, therefore we can take u1 is equals to 0 as well as u2 is equals to 0, and we will put the value in that mathematical expression of principle of conservation of linear momentum. Now I am just writing that mathematical expression again. It was m1 u1 plus of m2 u2, that is equals to m1 v1 plus of m2 v2. That kind of mathematical expression we have, and you have to substitute the value of u1 and u2 in that expression, because initially before the bombshell was fired u1 and u2 is 0, right? They don't have any velocity because the bombshell was not fired. Now when the bombshell is fired, all of the particles starts moving with some velocity, therefore v1 and v2 will never be 0. Remember that v1 and v2 will never be 0, because when the bombshell is fired, the particles in the bombshell will start moving with some velocity. Okay, therefore what we will do, we will substitute u1 is equals to 0 as well as u2 is equals to 0, right? Therefore the final expression of a bombshell when it is fired, that will be 0 is equals to m1 v1 plus of m2 v2. That kind of mathematical expression you guys already have, right? I hope you guys have understood that concept. Is there any doubt? You guys can tell me in that group. Okay, now we are just proceeding with the next topic. Let me delete it. And now the next topic is the recoil velocity of a gun. We were just discussing that topic and the network issue just happened. In the concept of recoil velocity of a gun, what was happening that initially if you are having a gun with a bullet, now initially the gun and the bullet is at rest, therefore the initial velocity of the gun and the bullet is 0. Therefore we are just taking u1 and u2 as 0, and we have to derive the final mathematical expression for the recoil velocity of the gun. Therefore actually in that case we have to move to the first slide. Okay, and if the gun if the gun if the bullet is fired, then you are just applying some force to the bullet. Now if you are applying some force according to the principle, according to Newton's third law, what do we know? If you are applying some action to a particle, then the particle will apply a reaction force to you, right? Therefore if you are applying some force to the bullet, then the bullet will also apply some force to you, and therefore the gun will move behind with a lesser velocity, right? Therefore the gun will move behind with a lesser velocity, and that velocity is known as recoil velocity of the gun, right? When you will just fire, you will feel a backward push, and that velocity we need, and for that we will just need a mathematical expression, right? Now let's move to the first slide. Now this is the first slide. Okay, now what was the mathematical expression for principle of conservation of linear momentum? That was m1 u1 plus of m2 u2, that is equals to m1 v1 plus of m2 v2. That kind of mathematical expression we have. Now initially the gun and the bullet was rest, that means u1 is equals to 0 and u2 is equals to 0. Now when you will just press the trigger of the gun, then the bullet will be fired. That means you are applying some force to the bullet, therefore the bullet will also apply the same force on you, and you will feel a backward push. Now what is m1 here? m1 is the mass of gun, right? Now m2 is the mass of bullet. What is u1 here? u1 is the initial velocity of gun, Now up to that part, just pause the video and write down all of the things that I have written in the whiteboard. Then we just have to describe rest of the part also. Okay, now I am just erasing that portion because I think that you guys have already paused it. Now for next of the parts, what we have written, that what is m1, what is m2, and we have described u1 also. Now what is u2 now? u2 is the velocity. It's not the velocity actually, it's the initial velocity, right? It's the initial velocity of bullet. Now what is v1 here? Actually v1 is the velocity of gun, that means the final velocity, but it should not be written in final velocity. It should be the recoil velocity, right? The recoil velocity of gun. Now what is v2 here? v2 is the final velocity of bullet, right? v2 is the final velocity of bullet. Now you have to pause this portion also and write down all of these things that I have written in my board. Then we will just proceed. Okay, I hope you guys have paused it, and now we are just proceeding to the next part. Now here in this case, what we are just doing, now we are just assuming that initially the gun and the bullet was fixed, therefore u1 is also equals to 0 and u2 is also equals to 0, because u1 is the initial velocity of the gun and u2 is the initial velocity of the bullet. Therefore that portion should be equals to 0, and we will get m1 v1 plus of m2 v2. Then minus of m1 v1 should be equals to m2 v2, right? Then what will be the final expression for v1? v1 is the recoil velocity, that is equals to m2 v2 divided by of m1, and the minus should come here. Now this is the mathematical expression we need to derive the recoil velocity of the gun. I hope you guys have understood the concept that how we have derived the mathematical expression for the recoil velocity of the gun. Right? Now we are just proceeding to the next topics. Okay? If you have any doubt in understanding the concept, you guys can revert me back in the group. Okay? Now you have to just pause that video now and write down the expression, because I'm just deleting that portion now. Okay, now let's proceed to the next topic. Now this is the first numerical that we are going to solve. Now at first pause the video and try to do on your own. Okay.